This recording is the second video for lesson 3.3 on creating simulations to determine probabilities. You've already watched one video that outlined the process that I want you to follow for displaying your work. And one thing that I did not mention in that video, and it's an important idea when you create the simulations, is to ask yourself the question that this guy is. Do I allow repeated numbers in my simulation for that situation? So is it proper that if my calculator gives me an 8, is it okay for it to give me an 8 again? Or should I disregard that and generate another random number? That's a really important idea, and we'll come back to that in this video. This video is basically just going to show you two more examples of exercises that would be similar to those in your assignment. So in the last video, you saw this screen where in each exercise you have 4 things to do. Decide how to write your random integer statement. Declare what each number would represent if it's generated. Generate the data, and then interpret the meaning of your data so you can answer the question. And I'm going to demonstrate those steps again in 2 examples here. So first of all, we in the past talked about a situation with left-handers, and I'm wondering if you remember that in that exercise it said 13% of the population in the world's left-handed. Well, here I want to create a simulation where it represents selecting 30 people randomly. And then out of those 30 people, I want to know whether they are left-handed or right-handed. So that's the task. Simulate selection of 30 people and decide whether they're lefties or righties. And so I think I've got it displayed here already. My idea was based on what percent means. Percent means out of 100, right? So 13% means out of 100. So I decided to generate random numbers from 1 to 100. Then I have to declare what each of those numbers mean. And I did that in black here already. I declared, first of all, that the numbers 1 through 87. Wow. I think I made a mistake. Let me go back. I did that wrong, didn't I? Lefties are going to be 13%. Wow, can I fix that here? I don't know what I was thinking. I actually did it backwards. These 88 through 100 would be the lefties, but maybe it would make more sense since you're viewing this. 13%, that'll be the numbers from 1 to 13 are the lefties. And then I'm going to change this, and I'm going to say that means then 14 through 100 would be the right-handers. So 1 through 13 will be the lefties, that's the 13%. 14 through 100 are the right-handers. So I've got my Randy statement. It's right here. I'm declaring what each of the numbers mean here. And then thirdly, I've generated my data, and it's right here. And I haven't done the interpretation yet, so let's do that. So I had 30 numbers. Let's see, the lefties are any of those numbers from 1 to 13 are lefties. So lefty, 3. There's another one. Lefty. Any more? I don't see any more. Oh, yep. Lefty. I think I got all the left-handers there. So now I'm going to interpret this. 1, 2, 3, 4, 5, 6, 7, 8. 8, whoops, sorry. 8 out of 30. 8 out of 30 are lefties. So I'm going to take my calculator and go 8 divided by 30. And that's telling me almost 27%. It's saying 0.26, and it's a repeating 6. So I'm going to say, in my experiment, I got about 27% of the people were lefties. That's kind of uncommon, right? And then I guess I don't even have to count the other ones. The other 22 out of 30 are right-handers, and that's going to be the other 73%. And so that my simulation got percentages quite a bit differently than the reality. Now, that would make me think maybe I should rely on the law of large numbers and repeat this experiment, but instead of picking 30 people, pick 100 people. And it's probably going to be more likely then that these numbers will be closer to the 13% lefties instead of 27% lefties. So that's my first example. Now, one more example, and then we'll end this video. Oh, by the way, in this video, I said an important question is, do I allow repeated numbers? And here, I would say yes, repeated numbers are allowed because I'm only generating a possibility of 100 different numbers, right, from 1 to 100. And there's millions, actually billions of people in the population. And so a number here isn't really equated to a particular person in the population. So I think it's okay for repeated numbers. That is different here. There's 24 numbers on this, members of this trap shooting team. And so here, when I generate numbers, as I indicated here, from 1 to 24, each number is going to represent a certain person on that team. And therefore, I can't pick the person twice. We should read the problem. The 24 people on the team, 5 of them are female. The coach needs to select 10 people to go to the away meet. She will make this selection randomly. Create a simulation of the coach selecting the 10 players. So we have to select 10 players. Well, you can't select the same person twice to go on the bus to the meet, right? So I'm going to say no to this question. Repeated numbers are not allowed in this scenario. So I'm declaring that I'm going to generate numbers from 1 to 24, and I'm not going to allow for repeats. And then do you remember here that 5 of the girls are female? So right here for the girls, I'm going to say the numbers, because this is just easier for me. I'm going to say the numbers 1 through 5 are the girls, and then 6 through 24 represents a guy. So then, after declaring my numbers, I generated my 10 numbers. Now, notice I actually had to generate 12 numbers because I had repeats. When I got this 15, I already have selected that person, so I have to throw that 15 out. And the same thing with this 8. I got another 8, and I had to disregard it. So I got my 10 numbers. And remembering now that I said any number from 1 to 5 is a girl, I'm going to go up here, a girl, that with a 2, there's a girl, and there's a girl. I got 3 females. And, sorry, let me try that again. 3 females and 7 guys, 7 males on my team. Well, 3 out of 10, that's 30%, right? And I guess I don't need the percent there, but that percent is higher than 5 out of 24, right? I got more girls than I expected, I guess is what I'm saying. And that's part of my interpretation of my data that I got. And to save time on the video, I'm not going to write it out here, but part of my interpretation would be to say that I selected more girls than I thought I would in my simulation. So that's the end of this second video, just showing you two examples again, where the important thing here is to follow this process. Randy statement. Every single time, we need a Randy statement. Declare what the numbers mean. Generate the data, make your interpretation. So there'll be one video to follow to talk about the birthday problem.